Buenas tardes, un gran placer estar aquí. Good afternoon, it's a real pleasure to be here. Thank you to Bay Awards and Resonance and World City to have us here. Co-founder of Intelligent Cities with me here, Cindy Wilson, over there, if you want to talk to her later. We founded Intelligent City with the mission to empower people to live better in cities. And we're an urban housing product company that has developed a set of technologies to overcome some of the major problems, help overcome some of the major problems that we see in our industry. And what I'm going to talk about today is about productization in the sector and how we can use advanced technology such as AI to help us overcome some of the challenges that are there. The main problems that we're facing in our industries, of course, we have an urban housing industry in crisis just about in any metropolis in the world right now. There's a fundamental lack of supply, of choice, of quality of homes, of cost effectiveness. It's there, and we're trying to do that in a sector that's already responsible for almost 40% of carbon emissions. And if we want to meet the demands that are there to house another 4 billion people in new housing units over the next 26 years, then that number will actually climb up to about 50%. So that's unsustainable with incumbent ways of construction, of typical ways of doing, either sprawl, further sprawl, or doing concrete construction in a more traditional way. And the third problem that we're facing is we're trying to address these two issues, sustainability and trying to decarbonize our cities on one end and creating housing supply and choice on the other end, in a sector that hasn't really seen any productivity gains over the last 75 years. So you can read that up in the reports from the World Economic Forum. You can see it in the McKinsey Global Institute reports from already a few years ago. And so that's a fundamental problem that we have not found ways to address labor shortages that we can everywhere that lead to an ever-increasing cost and therefore also reduce quality of the homes and choices that are available to us. So the approach that we've taken is move away from the individually engineered projects that we see right now that are over and over bespoke, and really with a little learning there to go from project to project to move to something what we call a scalable product, to move from a service-based industry to a product-based industry, so that we can have something that's consistent and that serves sort of the things I think that we as people can agree on. Qualities of good access to daylight, good access to ventilation, privacy, safety, connection to nature, the kind of fundamentals that are there, but also recognizing that individuals, we are different, right? And we'd like to have a certain degree of accommodating what we need individually. And that's sort of back to that quote there that I put there from Einstein, everything should be made as simple as possible, but also no simpler. So when we try to industrialize the housing sector, we need to find a way to accommodate repetition, scalability, and fast delivery of projects on one end, and then individualization on the other one with sufficient capacity. So to do that, we really start to focus on a more emerging scale in the urban environment that we thought is an outstanding opportunity, which is sort of a mid-rise. Some refer to it as the missing middle, some at the 15-minute city, but really the sort of 6 to 18-story realm that's been underdeveloped in many parts of the world, where you see still a lot of low-rise on one end of the spectrum or high-rise on the other end of the spectrum. That is an interesting sector too, because it allows us to take advantage of new technologies. And some of you may not be so familiar, but I think a lot of people start talking about mass timber as a material of the future that we have adopted as the sole material that we're using, because it comes from a renewable and sustainable resource. It sequesters, trees sequester carbon during growth instead of emitting, like concrete construction would have a lot of emissions during construction. Here you have a material that actually sequesters carbon into it. It is incredibly strong. It's very different from a stick frame building that you may be used to in the past. It's also fire resistant. If you ever try to light a log with a match, it doesn't really work because it will char, it will not burn. And it's the same with here. People love living with it because it's biophilic. It's a measurable improvement of people's happiness to live with a material like this. And then critically for us in this process of industrialization, it's machinable. So we can precision manufacture using this product. And there's a lot of experience in the world, carpenters and so forth, that we can retool and take them from what they used to do and bring them into factories and work with robotics, but use their knowledge about this natural material. So it's about this combination of a renewable resource with the power of like Industry 4.0 or some forms of artificial intelligence. Critically important in all of this is when we're trying to industrialize and create scale is that we create unified regulatory frameworks. And we've been working really hard on this in Canada. Our company is based in Vancouver, Canada, to work across the country. And I've just put this image up here, and some of you might remember at the beginning of cell phones that there were all these different standards, and you would travel from city to city or country to country, and your phone wouldn't work anymore because it wasn't integrated, right? And ever since we've had 5G technology, you can go anywhere in the world, and it's working for everybody, and it's sort of a platform, right? It's the same with anybody who wants to create a product, any manufacturer, car manufacturer, they have something to go through homologation, it's called. They don't have to test every single car that comes out of the factory. They test the platform, they test the car, and then they sell them by the hundreds of thousands. So we've taken a similar approach in the idea of productization, but we require a unified framework for this. And so what's really interesting now in North America, what you're having is you take Canada, which are the green provinces up above, all the ones in darker cream have basically adopted a new building code that allows for high-rise timber construction. So you can build now 12, in some provinces, even 18-story buildings, no questions asked, right? That's new. But you also see in the United States below, all the states shown in blue here have also adopted the International Building Code to allow for that up to 18-story timber construction. And the beautiful thing, and that's the opportunity for the first time, this new code is largely unified. So there is very little difference between what we do in Vancouver versus doing a building in Los Angeles versus a building in Toronto or in some of the other parts that you see on the map here. So that gives us a possibility to actually scale and make the capital investments to build factories and create solutions that work in all of these. And what we've done is basically said the classifications of buildings generally up to 6 stories, in some areas 7 stories, up to 12 stories, and up to 18 stories. And this is really just how the building codes have sort of shaped up. We worked on this for a long time. We've been really, for the last decade, worked directly with government agencies, sitting there and not just create the industrialization, but actually help shape that framework. So up to 6, 7 stories, depending where you go, those are all timber buildings. Up to 12 stories, they still have some steel cores or concrete cores, so they're hybrid. But they're fully exposed, meaning that when you walk into your home, you see basically all the timber, which is beautiful. Up to 18 stories right now. You can build it all with a load-bearing timber structure, but you will have a concrete core, and everything gets sort of pretty much clad with drywall, which is unfortunate, but we'll keep working on it. And there are examples right now where you see buildings that are built 18 stories. In Milwaukee is a 25-story building right now, and taller buildings on the drawing boards. It's not a novelty anymore. There are a lot of mass timber buildings in North America being built, and also across Europe now. So we create this classification, but also we look at different types. And that is important because not every city is the same, not every location is the same, not every client is the same. Climate conditions vary. So when we developed the systems approach, we created basically these forms of development that are important. And there are 2 parts to this to keep it really simple, but with enough adaptability. So we create the superstructure you see under B and the envelope under C. Those are already integrated, so they're modular, but they integrate electrical, they integrate ventilation. They're as much plug and play as possible, and they span freely. They don't require any beams, and they can be rapidly installed. And then these envelopes meet what is called a passive house standard, also a significant reduction in needs for heating and cooling in the buildings to keep the cost of the building down to operate them and to make them also longer lasting and protect the whole structure. And then importantly in all of this is there is basically a piece of software running in the background that's based on principles of parametric design and then machine learning to let these building platforms evolve and make the entire integration between the product and design, the engineering, the technology platform, and the scalability, create communication between all of these, because otherwise that doesn't work, right? If you just have to every single time go out again and hire an individual architect and engineer that don't understand it, you can't integrate into manufacturing. You wouldn't go into a car showroom and tell the salesperson that you want to have your car custom designed, right? It wouldn't cross your mind. You would just buy the product. In a similar sort of way, that works here. But we can accommodate that in that integration of the technology. So we have these two parts that are made for each other that can be rapidly installed. So you just install this panel here, and within 30 minutes, you basically have an enclosure that makes the building perform immediately to very high specs. And you don't have to go and touch anything anymore, right? You just hang these panels, clip them together, and you have essentially the shell with a lot of the systems already installed. And that allows just much quicker in construction. It brings costs down and so forth. So these can be customized as panels, so you can change the colors, the position of the windows, some of the shapes. You can accessorize them with balconies, with all kinds of things. And you can also adjust, of course, these floor systems so that they work for that specific project. And so the integration of the platform that we've built over the last decade is the building systems together with these sort of apartment libraries and different ways so that people can live happy lives in cities, that they're really about livability. And that gets productized like any good product that you would want, that you'd like to be with. They're not a cheap solution, they're actually a desirable solution, measurably so. Then you have the whole manufacturing technologies and the robotics that we've developed, and then we have, again, the whole software and the machine learning aspect of these platforms. So when we design buildings, they design almost themselves really quickly, everything about the homes. It comes from catalogs, we work with the groups, but in the background, the entire building system runs with all its data sets, so you know the cost, you know the carbon footprint, you know the delivery times, and we can sweet spot these projects. It goes into the whole logistics, how they get installed rapidly, make sure it all comes together so that collaborating people in the ecosystem that we're working with can do that, and the robot code is sent directly into the manufacturing line. So you have the flexibility of the design to some degree, and that gets translated into the manufacturing overall. So at any given moment, you know exactly where everything is, and that allows quantification, that allows performance, verification, and now you can go with confidence, because the big problem in our industry to introduce innovation is that people don't know if this is going to work. So key part to what we do is that all the parts, everything has been completely certified and has been co-evolved. And then we have the automation technology developed that we had to do from scratch. There isn't anything like this in the world at the moment, so you can't just go to a robotics company and order a system. We had to develop it from scratch to work so that we can have precision manufacturing to these components so that they really last and work as described for all aspects, from giving them dimensionality to assembling all the systems with a high degree of repeatability. But again, just enough adaptability so we can accommodate a huge range of needs in the buildings. So you have these robotic systems that became really interesting to sort of see what happens when you work with this material that comes from a renewable resource that is a bio-based material, and now you apply this sort of precision to it, and it changes your thinking about design, it changes your thinking about engineering, and what you can do with it, and how you from there can create sort of a larger idea of city making, because you figure out what the limitations are, but how far you can push it. And so the benefits are really, cost reduction, you gain speed, and those are pretty significant parts of it, but you also gain Adaptability, so you can have buildings that can adjust over time because you don't have any structural walls in them. They provide a lot of freedom for accommodating different user needs, demographic change over time. And then critically important, you can get to faster speed and carbon neutrality. So what I'm showing here is basically from a typical incumbent project at the top to something where we work with cities and we negotiate with cities how you insert a product as a design and then you can repeat that, right? And it's based on, again, a good quality of empowering people to live better, of creating resilient communities, really good typologies, but then productize that and repeat it, get quick approvals, be in and out quickly because parallel on-site, off-site construction, and then build it in such a way that you reduce the carbon footprint of these buildings. You see a concrete building on the left, and then to the right there, what happens when you do one of these timber buildings, where you can reduce the embodied carbon footprint, the operational carbon footprint, and the behavioral carbon in it, so that over the life cycle of a building, they can actually be carbon neutral in many ways. So you end up with a kit of parts that's very simple, but you can create from it a great amount of variation, a great amount of solutions that are there, so that we ask ourselves, like, look at a city like Tokyo, for example. It accommodates the life of over 30 million people. Could we build that with our system? And we could. So you can do about 95% of the buildings of Tokyo with a system like ours at this time. But you can also go and either do like more modern developments that you see in Northern Europe, or like, city of Barcelona or Bilbao. All of these can be done with our system today. So that's sort of the applicability of the range. And we work right now with the Canadian municipalities in Vancouver on the right, Toronto on the left, to work through programs of urban densification and along urban arteries, and that sort of productization that we can just sort of repeat the success of these buildings. As I said, they need to be adaptable, so lots of possibilities to shape the typologies, the building form, their articulation, how you can add accessories like indoor, outdoor balconies, screenings, vertical gardens, everything you need to sort of create a more varied city. So maybe in summary, a little bit about the environmental issues that really matter to us, that building better doesn't mean it's more expensive. The mass timber approach allows us to use a material that sequesters carbon, but it works beautifully in an idea of industrialization and repetition, and that brings costs down. It allows us to build buildings that perform better and use less energy, and we can do that repeatedly, and that brings costs down because you have to pay a lot less for heating and cooling. And then thirdly, these are systems that are designed for urban uses, for urban communities, for resilient communities, to give people what they really want is a good life in cities. And that gets people out of cars, that creates cities that have better public infrastructure investments, and bring everything into close proximity. That's what these buildings and systems have been designed for. So a quick run through projects we're doing right now for an Indigenous housing society in Vancouver, 9-story rental building, almost done, rapidly erected with these parts. And a lot of what we thought was proven out. We have complete precision of the materials. And as I said, a big panel like this, 10 meters long, 3 meters tall, would install in about 30 minutes in this. Just started construction on this one here in Toronto, on the other side of the country, another 9-story building. Interesting about that is that the owner, the client, wants to do a whole series of these, right? So this is the whole point of creating a portfolio approach around housing, that not every building is a one-off bespoke solution, but saying, I have a building that works well, that looks good, that creates happy people. Why would I not repeat the success, right? And that's exactly what we're starting to do here. A variety of typologies. You can have them with courtyard, without courtyard, depending on the climate zone. This is more like a West Coast style building with the courtyard, but allows natural cross ventilation to all the units, makes the units even more small and more affordable. And then the possibility to understand buildings in themselves as a sort of a form of a module, a form of a building block to build cities. And as you can see here, we're working with clients where they want to create communities for 6,000 people, 5,000 people, and a lot of the issues of activating the ground, pushing cars out of the way, making it pedestrian friendly, bringing families and children in, and all that is completely possible and compatible with this idea of then creating homes in a way of fairly high density, but really making sure that livability is always guaranteed, even if you go into something that's 12 stories on the right or up to 18 stories in the background. So maybe in summary, the journey that we've been on was really to get to certain milestones that were really important, get to market readiness, which we are now, and we're delivering this, that to be cost competitive, we're now actually cheaper than incumbent construction. The challenge we're facing is more, people getting their head around adopting something in an industry, something new in an industry that is typically very risk averse. Right? And as I said at the beginning, people have not innovated for 75 years because we have to appreciate that in the construction industry, people take risk of 20, 50, $100 million. And so they want to know that there's enough proof out there, right? But that's coming. We're seeing hundreds of buildings of this kind now, not just through us, but through the whole industry. A whole new ecosystem is emerging and flourishing around this. It's cost competitive. It's carbon negative as a form of construction. It can remain carbon neutral. And importantly, everything we're doing is completely tested and certified. We wouldn't go out there and not do that, right? So that's new in an industry, that you have something that's reliably put through everything from fire testing to acoustic testing to so forth to make sure that the systems actually work. It's simple, yet flexible, and it's of really high quality. So thank you. That's what I had to share.